There's two different ways to classify skeletal muscle fibers. So we can look at the speed of contraction. There are fast twitch and slow twitch muscle fibers. And then we can also classify them based on the way they make ATP. So there's either oxidative fibers or glycolytic fibers. So if we put those terms together, we end up with slow oxidative, and fast glycolytic fibers. Let's take a look at the difference between fast twitch and slow twitch fibers first. So this depends on the speed of the ATPase enzyme that's on the myosin head. The faster the ATPase enzyme works, the faster it breaks down the ATP and can pull the myosin heads back, then the faster it can do the cross-bridge cycle, and then the sarcomeres can shorten faster. So the fast twitch fibers have fast ATPase activity, and then the slow twitch fibers have slow ATPase activity. All muscles have both fast twitch and slow twitch fibers in them, but some muscles have more of one than the other. So the extraocular muscles that control eye movement, they have mostly fast twitch fibers. So they can contract really quickly and move your eyes very fast so you can see what's coming at you really quickly. And if you can compare that to the soleus muscle, which is in the bottom half of the back of your calves, those muscles have mostly slow twitch fibers. So they're going to contract much slower. And that's okay because the soleus muscles are just used for postural support. So they're just going to make slow contractions that are used to adjust your posture to help you stay upright. The gastrocnemius muscle, that's also located on the back of your leg, but it's in the upper part of your calf. And that is kind of in between the extraocular and soleus muscles. So it's about half fast twitch and half slow twitch fibers. And so that muscle has a different function. It's going to be used for things like jumping, running, and also walking. So you need a little bit of both slow twitch and fast twitch in the gastrocnemius muscle. And then we can also classify our muscle fibers depending on how they make their ATP. So oxidative fibers are going to be making their ATP by using their mitochondria and doing aerobic respiration. So they need a lot of oxygen, so they have lots of capillaries bringing in a large blood supply. They have tons of mitochondria. They also have myoglobin, which is related to hemoglobin. This is what myoglobin looks like over here. And it actually will store oxygen in the oxidative fiber. And then when oxygen levels are running low, the myoglobin can actually release oxygen so the mitochondria can keep making ATP. And just like the hemoglobin, the myoglobin also is a red pigment. So it makes the muscle look kind of a dark red color. And if you're eating some turkey, it's the dark meat. So if you look on the turkey, the dark meat would be like the drumsticks. And that makes sense because the turkeys walk around all day. And these oxidative fibers are very slow to fatigue because they can make lots of ATP all day using their mitochondria, and they're not going to be building up a lot of lactic acid. They do have a small diameter, so not a lot of actin and myosin in there, so they're going to have not as strong of a force of contraction, not going to generate as much tension. And they're going to be found in these small motor units. So they're going to be recruited to contract first when you're starting to pick up something. And then the glycolytic fibers, they're going to use fermentation to make most of their ATP. Remember, fermentation does not require oxygen. So they don't have as much of a blood supply and not as many mitochondria because they're going to be mainly using fermentation to make their ATP. And they also are going to be using glycogen stores a lot more than using up glucose from the blood to make the ATP. They also don't have any myoglobin to store any oxygen since they're using fermentation. So there's no red pigment. So this would make the muscle look more white in appearance. And it's also the white meat that's on the turkey. So this would be the breast meat would be the white meat on the turkey. And these glycolytic fibers have a large diameter, so lots of actin and myosin in there, so they're going to generate a lot more force than the oxidative fibers will. They're in the large motor units, and so they're going to be recruited to contract last. They're also quick to fatigue because they're using fermentation to make their ATP, and you don't make very much ATP that way, and plus you're also making lactic acid as well. So you can see why with turkeys, they don't fly very far because their breast muscles that they use to power flight, those are all glycolytic fibers. So they will give them quick bursts so they can fly short distances to get away from a predator, but they're not going to be migrating like to South America in the winter. They just will not make it. And here's just a cross section of a muscle. And what they've done is they've stained the mitochondria purple. So you can see this cell here has a lot of mitochondria in it, so this would actually be an oxidative fiber. And the one right below it does not have a lot of mitochondria in it, so this would be a glycolytic fiber. And the other thing to notice is the difference in the diameter. So you can see the oxidative fiber has a small diameter, not going to generate as much force. And then the glycolytic fiber has a much larger diameter, and that's going to generate a lot more force. The other thing to notice is that muscles are a mixture of both oxidative and glycolytic fibers. Okay, and a particular muscle may have more oxidative than glycolytic, or vice versa. So putting these terms together, we have three different types of skeletal muscle fibers. So we have slow oxidative fibers, fast oxidative fibers, and fast glycolytic fibers. And looking at a particular muscle, we are going to find all three of these types in a muscle. But different muscles are going to have different proportions of these fibers depending on the muscle that you're looking at. The slow oxidative fibers, they are slow twitch. The myosin ATPase has a slow contraction speed. They're oxidative, meaning that they're going to use aerobic respiration, their mitochondria, to make most of their ATP. So they've got a really big blood supply and lots of mitochondria. They do have myoglobin to store oxygen, and so this will be the dark meat. They do have a small diameter, which means they're not going to generate as much force. They're in the small motor units, so they're going to be recruited to contract first, and they fatigue slowly. So muscles that have a lot of slow oxidative fibers in them will be your postural muscles. So like the soleus muscles in the back of your calf, your back muscles, abdominal muscles, all of those muscles that you use to kind of keep you upright, those will have a lot of slow oxidative fibers in them. The fast oxidative fibers are kind of in between the slow oxidative fibers and the fast glycolytic fibers. So they're fast or intermediate twitch. So their myosin ATPase has an intermediate contraction speed. They are oxidative fibers, so they do use their mitochondria and do aerobic respiration to make their ATP. They have a big blood supply, lots of mitochondria. They have myoglobin, and this will be dark meat. The diameter of the muscle fibers, they're intermediate, so they will have an intermediate contraction force. And they're going to be in the intermediate sized motor units. So they're going to be recruited to contract second after the motor units with these slow oxidative fibers. They are slow to fatigue, but they do fatigue more quickly than the slow oxidative fibers. Muscles that we find a lot of fast oxidative fibers in would be ones that we use for, like, for example, for like walking and jogging. So, you know, your gastrocnemius muscles, quadriceps, hamstrings, muscles like that. And then the fast glycolytic fibers, they have the fast twitch, fast contraction speed. They are also glycolytic, so they're going to use fermentation to make their ATP. So not a lot of mitochondria, not a big blood supply. They don't have any myoglobin, so they're going to be the white meat. And they do have a large diameter, so they're going to create the highest force when they contract. And they're going to be found in the large motor units, and they're going to be recruited to contract last. So they're going to be in these high intensity exercising. That's where we're going to be using these fast glycolytic fibers, so like weightlifting and sprinting. They're also going to be fatiguing very rapidly because they're just using fermentation to make their ATP. So recruitment order, when you start to pick up something, for example, you're going to recruit the small motor units first, so that would be your slow oxidative fibers and the small motor units. And then if that's not enough power, then you kick in your fast oxidative fibers and your intermediate motor units. And if you still need more force, then you'd get your large motor units that contain your fast glycolytic fibers to contract. And this is a really nice table from your book that would be good to study. It compares all three types of skeletal muscle fibers. We've got the slow oxidative, fast oxidative, and fast glycolytic fibers. Muscle fatigue is when your muscle gets tired and does not create as much force, even though you keep stimulating it to contract. You can really see that in this second picture, where you're stimulating it to contract more quickly than you did on the top one. The top one, you're giving it more time to relax and recover in between the stimuli, so you're not getting a decrease in tension. But if you're telling your muscle to contract more quickly, you will eventually run into fatigue where you're not going to be able to generate as much force. And we've all experienced that before. And if you don't let your muscle relax at all in between the stimulus, then we're going to get complete tetanus. And you're going to fatigue much quicker. And if you do allow the muscle to rest in between, you can generate that maximum tension again, but it's not going to be as for long as what you did the first time around. And if you ever lift weights in the gym, you all know that because the first rep that you do on weightlifting, you do pretty well. But the second and third rep, you don't do as well as far as lifting the weights. And that's because of the muscle fatigue. As far as causes of the muscle fatigue, if you're doing the high intensity exercise like lifting weights or sprinting, you're using fermentation with those glycolytic fibers. So you're building up a lot of lactic acid, which changes the pH, and that changes the shape of the actin and myosin, and then they don't contract as efficiently. You're also compressing the blood vessels because the muscles are contracting so forcefully, and that's decreasing the blood flow into the muscles even more. And so, again, you're not getting enough oxygen in and not enough glucose in to make ATP. You can also get neuromuscular fatigue, where if you're stimulating the muscle to contract really quickly, you could actually run out of acetylcholine in that somatic motor neuron. That doesn't happen very often, but it could. And then if you're doing low intensity exercise, like maybe you're going for a long hike, or maybe you're running a half marathon or something like that, the muscles get fatigued there because you're running low on your energy reserves, so like glycogen and some of your other energy reserves. Other things that can cause muscle fatigue, changes in ion distribution because you are creating so many action potentials and maybe you didn't have time to put all the ions back where they should be, the sodium, the potassium, that can cause problems. And then also your mind has a big impact on how tired you feel. So if your mind just says, oh, I'm done, then you're not going to go anymore. So that would be psychological fatigue. Your skeletal muscles do adapt to use. If you don't go to the gym and are just sitting on the couch, your muscles will atrophy. So if you don't use them, you lose them. So your skeletal muscle cells say, hey, you know, we're not being asked to lift as many weights anymore or run or whatever we were doing. And hey, we don't need to maintain as much actin and myosin anymore. And so the skeletal muscle fibers will actually chew up some of the actin and myosin, and that will shrink the diameter of the muscle fibers. And so that will decrease the force of contraction. So that's why when you go to the gym at the end of the semester, you haven't been in a while, and you're like, well, I'll go back and do my same workouts. Well, you can't do it as well because your muscles have atrophied. But if you have been working out at the gym regularly, your muscles will hypertrophy. Hyper meaning an increase, and trophy is talking about growth. And as you work out and you're using the muscle more, your muscles will actually make more actin and myosin, and that will increase the diameter of the muscle fiber. And so that will increase the amount of force that's generated by the muscle cell. The muscles will not get larger. You will not get muscle hypertrophy because the muscles are dividing and producing more muscle cells. That does not happen. The muscles get larger because you're making more actin and myosin and you're increasing the diameter of the muscle cell. And the other interesting thing that can happen is the way that the muscle fibers make their ATP can actually be changed with training. So you could change fast glycolytic fibers into fast oxidative fibers, or vice versa. So maybe you have somebody who's been training as a sprinter, and now they go and say, well, I'm going to go run a marathon. Well, just by training, you could change a lot of those fast glycolytic fibers into fast oxidative fibers. And then you could also go the other way. If a marathoner wanted to start training for doing sprints, they could change some of their oxidative fibers into glycolytic fibers. But you can't change whether it's fast twitch or slow twitch. That is just genetically determined, and you can't change that. And that's why some people are better sprinters and some people are better at running marathons, and you can't change that.